So A would open up or down? Down, because of the negative. On vertex, you do opposite of B over 2A. You get negative 6 over negative 6, which is 1. Then you get your y, so you plug that in. And that gives you negative 3 plus 6 plus 1, which is 4. So the vertex is 1, 4. The axis, it is an equation. So if you just write axis is 1, I'm going to take off on that. It is a line, so I want the equation of the line. So it would be x equals 1. Okay, B, open up or down? Up. Because of the positive 4. Okay, then opposite of B over 2A. So that gives you an 8 over 2 times 4, or 1. Plug that in. So you get 11 minus 8, which is 3. So did you guys get a vertex of 1, 3? Axis of symmetry, x equals 1. I got those? Okay. So would this be a maximum or a minimum? Let me ask you that. Minimum. All right. On C, open up or down? So is that a maximum or a minimum? Good. Opposite of B over 2A. Did you guys get negative 1/4? So now we have to plug that in. Negative 1/4 squared would be 1 over 16. So we get negative 10.5. So your vertex is negative 1/4 or negative 0.25, comma, negative 10.5. Axis of symmetry, x equals negative 1/4. Okay, questions? Then the next piece on your notes we have the discriminant. So the discriminant is the thing under the square root in the quadratic formula. It's b squared minus 4ac. Okay, if you guys think about the quadratic formula, x equals opposite of b plus or minus the square root, b squared minus 4ac all over 2a. If you have the x equals opposite of b over 2a, what's that? That gives you the x value of the vertex. The other piece in this, b squared minus 4ac, is our discriminant. And sometimes we are solving a quadratic, so we might have to do the quadratic formula. Sometimes I don't actually care about the solution. I just care if there is a solution or what the solution might look like. And that's the case where we use the discriminant. So it gives us a way of predicting the solutions, knowing if they are real or imaginary without actually finding them all the way. So if you think about the quadratic formula, if that's a positive, if you have a positive thing under the square root, then when you do your quadratic formula, you have something plus that and something minus that. So you get two real solutions. If it equals 0, if you have negative b plus 0 and minus 0, what's true about those? They're the same thing, right? So we just get one real solution. Sometimes you might hear it say that it's a repeated solution because it shows up twice. Something plus that and something minus that, you get the same solution out twice. And if it is less than 0, what happens if you get a negative under there? Then we get two imaginary solutions. There are no real ones in that case. They're only imaginary. All right. What I want to look at next, we're going to see quadratic models pop up occasionally. So the formula where this is used a lot is the vertical motion equation. S of t represents height of an object. It's equal to negative 16t squared plus v sub 0t plus h sub 0. V sub 0 is beginning velocity, like velocity at time 0. H sub 0 is your beginning height. T is your time, and S is your height. So I think that's a box for you to fill in the blanks on your formula sheet or on your note sheet. So I'd like to do at least one example with this. We can do more if needed. And that's really all I have left in this section. We kind of hit everything yesterday. We're just talking about a few more pieces today. So here is our problem. A ball is thrown directly upward from an initial height of 75 feet with an initial velocity of 112 feet per second. Give a function that describes the height of the ball in terms of time t. So I'm asking you to basically just fill in the blanks in that formula I just gave you. I used S, didn't I, for my height? S of t, if I'm using the same notation as I had on this slide. So that's negative 16t squared plus v sub 0, that is your beginning velocity, which was plus h sub 0, that's your beginning height. So that would be 75. Just a couple comments on this. If you started on the ground, what would your height be? 0. Okay. Can velocity be negative? Velocity is like speed with direction. So it can be a negative. Positive means it's going up. If something were coming down, then it would have a negative velocity. So it is possible to have a negative velocity here. Part B, after how many seconds does a projectile reach its maximum height? And what is the maximum height? So first of all, tell me how we would do this by hand, if I wanted to know. I gave you a quadratic, and I want to know when it has its maximum. What am I asking you to find? The vertex, right? Opposite of b over 2a would give you your time. Then you could plug it in, and that would give you your height. I also want to show you how to do this on your calculator. So everybody needs a graphing calculator here. Okay. Let's go to our y equals, and we're going to type in our function and clear out anything else that's there. So so you don't have a T button, just use the X, negative 16x squared plus 112x plus 75. Just so we're all kind of looking at the same thing, just hit zoom number 6 for me. That kind of resets all of our calculators, so we're starting at the same spot. Now, if I look at this, is it showing me much? No. What kind of height did we start at? 75. So let's kind of adjust this. If you hit your window, you can adjust your X's and your Y's. Let's try adjusting our Y max. What do you want to try? 100. If your calculator, if you have a big window, you can adjust right underneath that. It says YSCL. That's the scale. That's what it counts by. So if I wanted to change that to like a 10, that would just speed my calculator up a little bit, just so it's not trying to count by ones all the way to 100. Okay. So here is my graph. Am I still seeing the vertex here? So what do I need to do? I need my y's to be bigger. So let's go back to our window. Let's make our y 150 this time and see if that gets it. So there's some guess and check here. We don't know for sure because we didn't calculate it by hand, although we could have. Is 150 big enough? No. So let's try 250? Huh?
200 doesn't.
Okay.
300.
300. Whoops, not 3,000. That would be way too much. Let's see if that shows us what we want. There we go. So that right there is where we have our maximum height. Now your calculator can find a lot of things for you. If you just use the trace button, I have to warn you that's not overly accurate because it jumps around a lot, so you're probably going to miss that point. What I suggest is if you hit second and then the trace button, it takes you into this calculate menu. What are we trying to find? A maximum, number 4 here. Okay, so your calculator, it needs help because this graph really keeps going forever. So it's going to ask me some questions. It says left bound. That's saying, where do you want me to start looking on this graph? So you just have to be somewhere to the left of that point. Okay, you can be really close, you can be a little further away, it's not going to matter. Just be somewhere to the left and hit enter. And then it says right bound. Where do you want me to stop looking? So I'm just going to use my cursor until I go past my point. And then I'm going to hit enter. So I'm telling my calculator, look somewhere between here and here and find my maximum. Then it asks me for a guess. As long as you've already done your left bound, right bound, you're close enough, you can just hit enter. And then it tells me. My x is 3.5 and my y is 271. So after how many seconds? That would be my time. So that was 3.5 seconds. The actual height is 271. We were in feet. Now, you certainly could have done that by hand. Okay, it's not hard to do opposite of b over 2a. I'm just trying to show you guys other options on these problems. Yes, sir? So I want for what interval of time is the height greater than 200 feet? So let's use our calculator for this. I want to know, when are we above 200? One thing you could do, if you go to your y equals, you could go to y2 and set that to be 200, and all it's going to do is draw that line in when the height is 200. So we are above that height from here to here. Do you guys agree with that? So we just need to find these points. We want to be exact, so again, hit your second and then the trace button. This is all the stuff your calculator can find for you. I want to know where those two curves meet, so what do you think that would be? Not as intersect. Number 5. Okay, it's going to ask me questions. First curve. It will automatically go to the first thing we entered in our calculator, so all you have to do is hit enter. Second curve, it automatically jumps to the next one, so you just hit enter. Then guess just get close to that first point and hit enter. And so it tells me my x is 1.393. So now to find the other one, we repeat that. We're going to go to second, trace, intersect again. First curve, just hit enter. Second curve, just hit enter. But for your guess, now you have to get closer to the second point. And that one tells me it's 5.6065. So in that time frame, you are above a height of 200. Does everybody understand how we got that? One more question. It asks me when my ball will hit the ground. If you hit the ground, what's your height? 0. There are two different ways of doing that. Okay, if you don't want to learn anything new, we can do it the same way we did this example right here where we found the intersection. Except if we hit the ground, what do we want the y2 to be? 0. So if you want to do that, then you can just look for the intersection. First curve, second curve. So I've got my parabola. There's the height of 0. So second, trace, intersect. First curve, enter. Second curve, enter. But when it hits the ground, which point am I looking for? This one over here. So you have to get close to it. And it's 7.62 seconds.
Didn't we also do second trace and...
You can do a 0. So the other option, if you don't enter that second curve, where it hits the x-axis is a 0. And, oh, my calculator's going to freeze me. Here it goes. Then it's going to be like the maximum where it's going to ask for a left bound, a right bound, and a guess. So left bound, you have to be before that point. Right bound, you'll be after it. And your guess is in the middle. So two ways of getting that. Are we okay with this? Do we need another one, or is that enough? So we've got some time to work on homework today. I want you here's your assignment. You've got the rest of the hours to work and ask questions. Also, tomorrow I would like to do a quiz. I think I may have mentioned this yesterday over section 2.8 and 3.1. So 2.8, that was looking at our functions, compositions, domains, all of that. And then 3.1 is this quadratic stuff. So tomorrow we will grade homework, and then I do a brief review